Hello everyone, welcome back to my channel. I am Tux and today I am going to explain my major project based on artificial intelligence and machine learning. The title of my project is Water Potability Prediction System, where we analyze various chemical properties of water and predict whether the water is safe for drinking or not. I will explain every line of the code and the entire workflow step by step. So make sure to watch till the end. To start the project, first I imported all the necessary libraries. We imported NumPy and Pandas for working with numerical and tabular data. We used Matplotlib and Seaborn for data visualization plotting graphs. From sklearn, I import train test split for data splitting, logistic regression, and decision tree classifier for building classification models, and confusion matrix, accuracy score, and classification report for model evaluation. I also imported warnings and ignore warnings messages to keep our output clean. After importing libraries, I loaded the dataset using pd.readcsv, waterpotability.csv. Our dataset contains 3276 rows and 10 columns including pH, hardness solids, chlorinase, sulfate, conductivity, organic carbon, trihomolethins, turbidity, and the target column potability. Potability is the output where 1 means the water is potable and safe for drinking, and 0 means it is non-potable. After checking the df.shape, df.columns, and df.info, we observed that some columns like pH, sulfate, trihalomethanes had missing values. Missing values can reduce our model performance, so we identified them using df.isnull.sum and df.isnull.mean into 100. To handle missing values, instead of dropping the rows, I used mean imputation. I ran a loop that checks each column, and if it has missing values, it fills them with the mean of that column using fillna dfi.mean in place is equal to true. After filling, df.isnull.sum returned all zeros confirming that our dataset is clean. Next, I checked our duplicate row using df.duplicated.sum, and fortunately it returned 0, meaning no duplicate entries were present. Then I moved to outlier detection. Outliers can heavily impact model training, so I used the IQR method. First, I calculated Q1 and Q3 values using df.quantile. Then found the IQR. Lower and upper bounds were calculating using Q1 minus 1.5 into IQR and Q3 plus 1.5 into IQR. After applying filtering, the dataset reducing from 3276 entries to around 2666, which means noisy extreme values were removed. This helped in improving model training quality. Now I perform a correlation analysis to understand the features relationship using sns.heatmap. df.correlation cannot is equal to true. I generated the heat map. Here we can observe that no single feature is strongly correlated with potability, which means potability depends on combination of multiple factors. That's why machine learning is suitable for this problem. Next step is preparing data for training. I separated into features and output labels. X contains all independent columns except potability, and Y contains the potability column. Then I splitted data into training and testing set using train test split with test size is equal to 20%. This means 80% data is for training and 20% data is for testing. After splitting, I applied feature scaling using standard scaler. Because values like solids are in 1000 and pH is around 0 to 14. Scaling brings all values to a similar range so that model train better. I feed the scaler on training data and transform both training and testing values. Then I started model building. First, I train a logistic regression model using lr.fit, xtrain sc and ytrain. After training, I checked the training and testing accuracy. Logistic regression gave around 62% accuracy on training data and 64% accuracy on testing data. It is not very high but work as a good baseline model. Then I tried decision tree, which usually performs better for classification dataset. I used decision tree classifier max depth is equal to 5 and trained it with dtree.fit X train SC and Y train. After prediction and evaluation, the training accuracy came around 72% but test accuracy around 63%. To understand the performance better, I printed the classification report which showed precision, recall and F1 score. I also visualized confusion metrics for both training and testing to check how many samples were correctly or incorrectly predicted. Finally, our conclusion is that decision tree perform a slightly better than logistic regression, but both models give around 63 to 64% accuracy. With more improvements like random forest, hyperparameters tuning, or using more data, we can increase the performance further. This water potability prediction model can help water quality monitoring system and assist it identifying safe and unsafe drinking water without costly lab tests. So this was my complete major project explanation of water potability prediction using machine learning. I covered data loading, pre-processing, missing value handling, outlier removal, visualization, feature scaling, model training, comprehension and evaluation. If you found this project helpful, make sure to like the video, comment your questions and subscribe for my AI ML content. Thanks for watching and see you in the next video.